Um, Hello everyone. Today I will present my final project of wireless communication class. My topic is analysis of block type channel estimation methods in OFDM systems. First, I will introduce the OFDM systems and we will go to the detail of it, and then I will show you the different types of channel estimators that may be implemented in the OFDM system. Then I will show the simulation result and draw conclusion based on these results, and finally I will give you a demo. The orthogonal frequency division multiplexing OFDM system is a data modulation method which can provide high transmission capacity and also high bandwidth utilization. And due to these properties, it is widely used in digital video broadcasting, digital audio broadcasting, and will also be a competitive solution in 4G wireless communication areas. The OFDM systems could be treated as the improvement of the traditional frequency division multiplexing systems. And first, let's get started with discussing the traditional FDM systems. The traditional FDM systems divide the bandwidth into multiple sub-frequency bands, and each sub-channel will use the whole bandwidth of a sub-frequency band. The reason to do this is that to eliminate the interference of the adjacent channels due to there are no signal overlapping of these channels. But it will introduce the problem that low bandwidth utilization. So the OFDM system is designed to solve this problem. It still divides the whole bandwidth into some sub-frequency band, but now the adjacent subchannels could overlap in the spectrum. And the signal of the nearest two subchannel is orthogonal. And due to this orthogonality, even though the signals are overlapped in the frequency band, it still do not interfere with each other, but the bandwidth could be saved a lot. This figure shows you the baseband module of the OFDM systems. The input data will first be modulated. The modulated method could be various, such as QAM and PSK constellation. Then the data will be parallelized to be the input of endpoint IDFT, the inverse discrete Fourier transformation, which will transform the data in the frequency domain to the time domain. Then the transformed signal will be serialized again, and the cyclical prefix will be inserted into these signals. And the DAC converter will convert the digital signals into analog signals and then transmit these signals on the fading channels. In the receiver end, the ADC converter will first convert analog signal back to digital signal and remove the cyclical prefix. Then the data will be serialized to be the input of endpoint discrete Fourier transformation, which transforms the data from time domain back to the frequency domain, and then parallelize it, and demodulate the data after parallelization, and the output data will be generated. Then I will show you some different type of channel estimators. The channel estimators can roughly divide into two categories. One is called blind estimation, another is called pilot-based estimation. The blind estimation is not practical in the OFDM system because the OFDM system is used in wireless channels, which means that wireless channels are time variant and also it's not slow fading channel. So the transfer function may have a huge change during the transmission, and also so the estimation of this transfer function is not practical. So the pilot-based estimation, which inserts the pilot into the signals in the OFDM blocks, are more practical. So the pilot-based estimator can further be classified by two-dimension insertion and one-dimension insertion pilot estimator. The fading of the channel could be treated as fading of two dimension. One is the time dimension, another is frequency dimension. So the ideal implement of pilot-based estimator, considering minimize the mean square error metric, is mastered to insert the pilot in two dimension, but inserting the pilot in both time and frequency dimension is so complicated and not practical to be implemented in the real-world OFDM system. So the one-dimension insertion are used more in the real world. And depends on the pilot insertion dimension, it can also be further classified by block type, which inserts the pilot signal in the time dimension, and combo type estimator, which inserts the pilot in the frequency dimension. In our project, we only focus on the block type estimator, which inserts only the signal in the time dimension periodically, just as this figure shows. So in this project, I will discuss two different type of block type channel estimator. One is called LS estimator, the least square estimator. The matrix this estimator designed to minimize is shows in this function. The estimation function of LS estimator is shows in this equation. As we can see, this equation is so simple, and so it results in low computation order, but it also results in high error rate. The MMSE estimator, the minimal mean square error estimator, it tries to minimize the metric of mean square error. The estimation function could be represented in this equation. As we can see, it's much more complicated than the LS estimator. Then in this section, I will show you the simulation result of these two different kind of channel estimator comparing to the actual channel. These two figures represented the magnitude of coefficients of the estimated channel and actual channel using two different kind of constellation method. One is called QM, is shows in the left figure, and another is PSK mapper, which shows in the right figure. As we can see, the result of SE estimator is more closer to the actual channel than the LS estimator. These two figures shows the bit error rate, which could be also a metric to evaluate the accuracy of LS metric. The estimators. As we can see, the bit error rate of original channel will drop down significantly when the signal to noise ratio become larger. And also the MMSE estimator also dropped down a lot during the signal become much more stronger. But the LS estimator still keeping the high bit error rate. As the previous results shows, we can draw such conclusions. The LS estimator has low computation complexity, whereas suffer from high bit error rate. The MMSE estimator has higher computation order, but can estimate more accurately and has low bit error rate. Then I will give you a demo of simulate these two estimators in the OFDM systems in the MATLAB code. Let's take the PSK constellation method as an example. This figure shows the magnitude of coefficients of the actual channel comparing to these two different kinds of channel estimator. And this figure shows the bit error rate as a function of the noise signal to noise ratio of both original channel and the two block type estimator. Thank you for watching my presentation of my wireless communication class final project.